Good morning, students. So today we discuss about a new chapter, that is mechanical design of transmission lines in electrical power transmission system subject. This is under unit 3 as per JNT syllabus. So in this unit we discuss about the mechanical design of transmission line, that is nothing but insulators, concept of corona, then SAG. These three topics we have to discuss. So first of all, what is the main main concept of overhead transmission lines? Main introduction to overhead transmission lines. After then, we have to discuss about the mechanical sag, mechanical design, that is sag, tension, and also concept of corona, insulators. First, the overhead transmission line will be universally adopted. That is nothing but compared to the underground. So overhead transmission line is more beneficial, and it is universally adopted. That's why we go for in general practical way. So overhead transmission line is more adapted compared to the underground system, and it may subjected to storm weather conditions and external interfaces also. That means it may give a good operation in overhead transmission lines, depends upon the great extent, and because conductors having more mechanical strength such that they will give a good operation. The overhead transmission line has the following components. What are the components consisting of the overhead transmission lines? So these are the overhead transmission line conductors. So these are the conductors. What is the main work of conductor? Conductor may carry the power from one point to another point. Simply say that sending end to receiving end stations. Conductors are made up of ACSR conductors, steel reinforced aluminum conductors, right? So already discussed about the first unit. Next, supporters. So these are the supporters. It provides a support to the conductors, and that is nothing but the conductors may be put into some level, some height from the ground. These are those are the supporters. Next, insulators. So these are the insulators. So insulators provide the electric insulation between the conductors and tower or earth. Provide electrical isolation to poles mainly. Next, cross arms. Cross arms provide the support to the insulators. So conductors, different types of conductors is there, already discussed about in the first class. Copper conductor. So copper conductor having main high conductivity material and also good tensile strength. So 97.4% of conductors may be copper conductors, but because of cost wise, non-availability of the transmission system. That's why we cannot utilize copper conductors. But copper conductor is the best conductor, that is high conductivity, greater tensile strength, and these are also called as ideal conductor. Why we are calling as ideal conductor is nothing but, so it is having high conductivity compared to all other conductors. Next one, steel core copper conductors. So this is at the starting steel is there. Around that steel, we have utilized copper. Steel core copper conductor SCCC. Steel is used in the center, inner periphery, center surrounded by the copper conductors. Tensile strength and flexibility increases, but this is also high cost. Availability is low. Cadmium copper conductors, triple C. It is a alloy of cadmium and copper. Tensile strength increases 50% than the copper alone. Only copper uses tensile strength is high, but by using copper, cadmium copper, the tensile strength will increases more than 50%. But the conductivity will be reduces. Whereas in copper, high conductivity material, good tensile strength. But coming to the cadmium copper, tensile strength increases more than the copper, but conductivity reduces compared to the copper. That's why you cannot consider this one also. But but it is also costly, and that's rarely used also. Next, all aluminum conductors, AAC, is also used in 61%. Only aluminum is used. Aluminum is having low conductivity as compared to copper. Tensile strength is very low, light in weight, cheap in cost. Now this one, steel core aluminum conductor, SCAC, or aluminum conductor steel reinforced ACSR conductor. This is the best one for utilizing. Nowadays we are utilizing ACSR conductors to increase the tensile strength, and steel is here used, steel reinforced aluminum conductor. As diameter increases, so corona loss is reduced compared to the copper. As diameter increases, generally copper loss are increases, corona loss are increases, but here corona loss is reduced compared to the copper. Weight is very less, 70% of the copper. It is very suitable, well suitable for nowadays transmission line systems. So that's why now we are utilizing aluminum conductor steel reinforced, otherwise steel reinforced aluminum conductor. Here the conductor is, the steel is having the center and surrounded by the aluminum conductors. Steel conductor is low quantity and aluminum conductor is high quantity. That is nothing but, suppose for example 24/7 ACSR conductor. That means 24 is the aluminum conductors and 7 is the steel conductors. Last one, all aluminum alloy conductors. So, but it provides a better tensile strength compared to the ACSR, but it is having low conductivity. So that's why it is suitable for urban areas only, populated urban areas, populated industrial areas. Density of people is more, where density of people is more, at that situation we are utilizing all aluminum alloy conductors. But in overhead transmission system, we are utilizing as ACSR conductor, steel reinforced aluminum conductor, or aluminum conductor steel reinforced. Supporters, line supporters, generally supporters. A tower is having constructed in the earth. It is supporting structure of transmission consists of poles and towers, maintaining the proper spacing between the conductors. Suppose there is no poles, means the pole to pole gap is very high, long distance will be there. At that time, conductor may be touched to each other. That may gives sparking between two conductors. So that's why regular distance, the poles are arranged in a regular intervals that may provide spacing between the conductors to provide minimum ground clearance of conductor and earth also. To provide minimum ground clearance to earth and conductors. Line supporters should have following properties: high mechanical strength, cost is low, good life, and also market availability. In the market, the line supporters are availability of line supporters is very, very high. Sometimes we are utilizing a wooden poles or the line supporters. The types of line supporters: wooden, steel, concrete. But first of all, wooden poles. So the wooden poles will be utilized in rural areas only. That may be voltage is less than 11 kV. Compared to all other poles, line supporters, the cheapest among all line supporters. So wooden poles is the cheapest one. The cost is very low. It can be used for short distance up to 50 meters transmission line in the distribution system. Highly insulated because it is a wood, right? That's why mostly used for distribution system only. So these are the, look at the picture. These are the wooden poles. The wooden poles may be utilized less than 11 kV and cost is less and highly insulated because of wood. That's why it is utilized more in distribution system. But lifetime is less. Lifetime is less, and so some periodical and time to time inspection is required for this one. That means repair and maintenance cost is more. So two types of wooden poles are used: single pole shaped, double pole shaped. Look at the picture. This is the single pole shaped and this is the double pole shaped. Next one, RCC poles recently have become more popular because of high mechanical strength, and it will having longer life compared to the wooden poles, but it will have a small maintenance compared to the wooden poles. RCC means reinforced concrete. So good insulating property, and these are suitable for 11 kV. High cost of transportation due to the heavy weight. Because of heavy weight, so transportation from one point to another point to construct the transmission system, that is the more. Next one, steel poles. Nowadays we are utilizing more and more. Concrete is popular, but steel poles are more utilized nowadays. Good mechanical strength, and it possesses a longer life and can be utilized for the longer distance than the wooden poles and concrete poles also. And steel poles are utilized for higher voltages, extra high voltages. Double circuit steel poles may provide continuity of power supply. Right? These are the what is overhead system, then what are the components of overhead system, line support, I mean components, that is insulators, conductors, line supporters, right? Now go for the main topic, that is insulators, right? So an electric insulator, generally what is meant by insulator is nothing but it provides a insulation between the conductor and earth. That means insulator is a material whose internal electrical charges do not flow freely. The electric current do not flow freely, and which therefore does not conduct an electric current. A perfect insulator does not exist. Some materials such as glass, paper, and Teflon, which have high resistivity and very good electric insulators. Glass, paper, Teflon. Insulators are used in electric equipment to support and separate the electric conductors without allowing current through themselves. Right? Generally, the overhead line conductors should support the poles in such a way that current from the conductor do not flow to the earth. That is, line conductor must be properly insulated from the supporters. This is achieved by the line conductor to support with the help of insulators. The current flowing through the conductor does not flowing through the earth, that may be restricted with the help of two materials. One is line supporters, another one is insulators. Mainly insulators. Insulators provide necessary insulation between the conductor and supporters. Line supporters and conductor, there is no current flowing through the conductors and line supporter because of insulators. It may also useful to prevent any leakage current from the conductors to earth. In general, the insulators should have the following properties. Mainly, so look at the figure. The spacing between the horizontal spacing 11 meters, vertical spacing from earth to conductors is 41.6 meters. 220 kV, 320 meters. 110 kV, 320 meters. So for 111 kV, 110 kV, so this is distance is 5.75 meters, and distance is like this. Conductors to insulators 4.5, insulator to insulator 3.35 meters. Like that, we have to provide some spacing between the conductors and insulators, conductors and earth also. So these are the properties of insulators. Mainly, remember mechanical strength. Mechanical strength. Look at the insulator is nothing but mechanical strength. A good mechanical strength, otherwise high mechanical strength, in order to withstand the conductor load and wind or whatever it may be. Some natural effects will be affecting the conductors in the overhead transmission lines. These are all effects may be sustained. So whenever a conductor having a good mechanical strength. Next one, high electrical resistance of insulator material in order to avoid the leakage current to the earth. The insulator having high electrical resistance property that may avoid current flowing from the conductor to earth. Next, high relative permittivity of insulator material. High relative permittivity is nothing but in order to having high dielectric strength. Dielectric strength is high is nothing but, so it does not damage much more time. So insulator material should be non-porous. That is, non-porous means free from impurities and cracks also. Otherwise, if crack is occurred, the relative permittivity will be low, right? Next one, it is having high ratio of puncture strength to flashover. So the ratio of puncture to flashover is greater than 5.0, then the breakdown of insulator is mostly avoided. And generally, most common used material for insulator of overhead transmission line is porcelain. Porcelain main, but glass, C-type and special composition of materials are also used for limited extent only. Glass is used. Glass is replaced by the porcelain because of high mechanical strength and good electrical resistance also. The porcelain is produced by firing at a high temperature. A mixture of kaolin and feldspar and quartz. It is stronger mechanically than glass because of all these things. It gives less trouble from the leakage and less affected by the change of temperatures. That's why if change of temperature is occurred, or leakage current will be available and mechanical strength is low, all these drawbacks will be filled with porcelain insulators. So porcelain insulators have good mechanical strength and it avoid leakage current, and it will it will sustain the changes in temperature also. What are the different types of insulators? There are several types of insulators there, but most commonly utilized pin insulator, suspension type insulator, strain insulator, shackle insulator. The most important topic and most important question also. So types of insulators: pin, suspension, strain, shackle insulators. Go for the first pin type insulator. Look at the picture. The spin insulator is used less than 11 kV, that is rural areas, villages. Less than 11 kV voltages we are utilizing pin insulators. It is having single insulator at the topmost of the pin insulator having groove. In this groove, from this through this groove, conductor is passing. Right? Look at the picture clearly. So pin insulator consists of a non-conducting material such as porcelain. Pin insulator is made up of porcelain or sometimes glass also. As the name suggests, the pin type insulator secured to the crossarm on the pole. So it will put on the top of the pole. That is nothing but it will put on the crossarm. There is a groove on upper end of the insulator for housing the conductor. So look at the picture. So this is the groove. Through this groove, conductor is passing. Conductor passes through the groove and is bounded by the unlaid wire of the same material as the conductor. Pin type insulators are used for transmission and distribution system less than 33 kVs, but generally you can say that 11 kVs, but it may be used up to less than 33 kV. Beyond 33 kVs, the pin type insulators may become too bulky and hence uneconomical. That is nothing but it may broken. So look at the picture clearly. This is the concrete RCC pole and these are the cross arms. Now we are putting, so these are the pin insulators and this is the groove, topmost of the upper of the insulators having groove. So look at the picture clearly, this picture. So this is the groove. From this groove, conductor is housed or conductor is passing through this groove only, right? The name suggests the pin type insulators is secured cross arm on the pole. There is a groove on the upper end of the insulator for housing the conductor. The conductor passes this groove and is bounded by unlaid wire of the same material of the conductor. So this is the groove. Look at the picture clearly. This is the groove and shielded. This is a galvanized steel pin. So look at this picture. So this is the pin type insulator and this is the groove and conductor is like this. Conductor will be like this. Pin type insulators as earlier said that pin type insulators are used in transmission system for lower voltages. A single pin type insulator is used to transmit the voltage up to 11 kV, and higher voltages require 2 or 3, 4 pieces of pin insulators. So below 11 kV, single pin insulator is enough. So more than 11 kV, up to 33 kV, we may utilize 2 or 3 or 4 type of pin insulators. They are not economical more than 33 kV, right? So mainly application wise, the pin insulators are used straight poles, that is straight running transmission system. It is not utilized in curvature system or crossroad or railway crossings. It will be utilized only straight running transmission system only. Next one, the more important one, from this suspension insulator, competition exams, more objective questions are asked. So this is the suspension type insulators. So look at the figure. This is the glass type of suspension insulator. Nowadays we are utilizing also. For voltages greater than the 33 kV, for volt up to 33 kV, we are utilizing pin type insulators. Greater than 33 kV, it is usual practice, we are utilizing suspension type of insulators. Look at the figure. It consists of number of porcelain discs connected in series by a metal links and to form a string. Here 3 insulators will be there connecting through a metal and form a string insulator. So here from this figure 4 insulators are connected in series. So look at the figure 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 like that. So number of discs are connected in series to form a string, right? So each disc may rated at 11 kV here. So every disc may rated at 11 kV. So the conductor is suspended from the bottom of the here. These are the cross arm. This is the bottom of the insulator. Now the conductor is connected at the bottom of the string, while other end the string is connected to cross arm. Each unit or each disc designed for low voltage, that is 11 kV. The number of discs in series would obviously depending upon the working voltage. Suppose for 66 kV, we are utilizing 6 discs. For 110 kV, we are utilizing some more discs. For 220 kV, we are utilizing some more discs. Like then as voltage rating increases, the number of discs are also increases. Suspension type insulators have the number of interconnected porcelain discs with each individual unit designed to support the particular high voltage. Like this, the insulator, a cement, and we have to arcing horn, both are, this is the arcing horn. Together, a system having these discs is capable of effectively supporting high voltages. There are 3 types of suspension insulators are there: cemented cap insulators, interlinking, and core suspension type of insulators. What are the main advantages of suspension type insulators? Suspension type insulators are very less in cost than pin type insulator, voltages beyond the 33 kV. Each unit, as already discussed, each unit of suspension type insulator is designed with a low voltage of 11 kV. Depending upon the working voltage, the number of discs are reduces or number of discs are increases. If any one disc is damaged, suppose 6 discs are there, so 4th disc is damaged. Now we replace that 4th disc. Replace that 4th disc with a new one. Then, as usual, the 6 discs will be available as working. Suspension arrangement provides greater flexibility to the line. The connection at the cross arm is such that insulator string is free to swing in any direction and can take up the position where mechanical stresses are minimum. Suppose in case of increase in demand on the transmission line, it is found more satisfactory to supply greater demand by raising the line voltage. That means to provide a set of conductors adding in series with the already existing one. The additional insulation required for the raised voltage can easily obtain in the suspension arrangement by adding the desired number of discs. Suspension type insulators are generally used with steel towers, as the conductors run below the earthed cross arm of the tower. Therefore, this arrangement provides a partial protection of lighting, and it may be arranged in a horizontal manner, not vertical. Suspension type insulators are arranged in a horizontal manner. Next one, strain insulators. Look at the figure. When there is a dead end of the line, or there is a road crosses or corner curve, or it may be sharp curve in the road section. So suppose the line is subjected to greater tension. So in order to relieve the tension from the conductor, a Shackle type insulators are used as strain type insulators. However, for higher voltages, the strain insulators are consisting of assembly of suspension insulators as shown in figure. Here, the strain insulators may be arranged in a vertical manner. When the tension in lines is extremely high at long river spans, two or more strings are used in parallel. Strain insulators are horizontally suspended by suspension insulators. They are used to handle the mechanical stresses and take the pressure of conductor at the end of the transmission line. Mainly strain insulators are used in corner or curve or over long river crossings. So these are mainly utilized for higher voltage transmission systems. Next, shackle insulators. Shackle type insulators, similar to the strain type insulators, which are used on small sharp curves and end poles and section poles. Look at the figure. This is the shaded shackle insulators and will be suspended in between the D-strip and bolt. However, unlike strain insulators, shackle insulators are designed to support the lower voltages. These insulators are single and rounded porcelain pots that are mounted horizontally or vertically. Whereas in suspension insulators are used in horizontal, strain type insulators are used in vertical, but shackle both versions. But nowadays they are frequently used for lower voltage distribution systems. Such insulators can be used either in a horizontal portion or in a vertical portion. They can be directly fixed to the pole with a bolt or cross arm. This is the pole and uh, this is the shackle insulators that may be connected directly to the bolt. So another modules of shackle insulators. Thank you. So now third unit. So topic of types of insulators is completed. Next class we discuss about the voltage distribution of insulators. Thank you one and all.